If it's with the current, it's smoother sailing. So, next time you check the NOAA wave forecast, remember, always factor in the wind. Out on the open ocean, waves are a powerful force. They are generated by wind and travel vast distances. Understanding wave patterns is crucial for maritime navigation. The National Oceanic and Atmospheric Administration provides comprehensive wave forecasts. These forecasts are essential for anyone venturing out to sea or along the coast. They offer insights into wave heights, periods, and directions. I'll show you how to read NOAA wave forecasts like a pro. Let's start with the basics. NOAA uses a variety of methods to predict wave height, including models and calculations. The Nearshore Wave Prediction System, NWPS, uses the SWAN model to predict wave height, accounting for tides, storm surge, and wave current interaction. The model produces wave spectra, integral wave parameters, and tracks wave systems individually. Wind strength, duration, and fetch are crucial factors. Strong winds make waves bigger and more chaotic. Gentle winds, smaller, calmer waves. Wind must be moving faster than the wave crests to transfer energy. Heading across the Gulf Stream, be extra cautious. If the wind is against the current, waves get rough and steep. If it's with the current, it's smoother sailing. So, next time you check NOAA wave forecast, remember, always factor in the wind. NOAA wave forecasts are available online and through weather apps. They use advanced models to predict wave conditions based on wind speed and fetch. Data from buoys, satellites, and coastal stations provide a detailed picture of the ocean's surface. Understanding these forecasts helps us make informed decisions about safety and enjoyment on the water. One of the most fundamental pieces of information in a wave forecast is the average wave height. This figure represents the mean height of the highest 1/3 of waves observed. It focuses on the larger waves, which are more significant for marine activities. Knowing the average wave height is crucial for assessing sea conditions. Average wave height is typically represented in feet or meters. It is determined by analyzing data from buoys and other observational tools. Larger waves carry the most energy and impact vessels and coastal structures. The average wave height provides a useful snapshot of wave conditions. However, it is essential to remember that the ocean's surface is a dynamic environment with waves of varying heights. In reality, waves don't all conform to the average height. They exist on a spectrum, from small ripples to towering giants. The average wave height merely provides a reference point within this spectrum, helping us understand the general conditions. Around this average, there's a distribution of wave heights. Roughly 2/3 of waves will be within a range above and below this average. For example, if the average wave height is reported as 4 feet, most waves will likely range between approximately 2.5 and 5.5 feet. Understanding this distribution is crucial for safety on the water. While the average wave height might seem manageable, it's essential to be prepared for the occasional larger wave. These larger waves, though less frequent, can pose a significant risk, especially to smaller vessels or swimmers caught unaware. Understanding peak wave height While the average wave height provides a general idea of wave conditions, the peak wave height represents the highest waves you might encounter. This figure is significantly larger than the average wave height and is crucial for understanding the full range of wave conditions. Peak wave height is not a regularly reported statistic in NOAA forecasts. However, it's essential to understand its implications. Peak wave height is typically several times higher than the average wave height. This difference highlights the importance of considering the entire wave spectrum, not just the average. In rough sea conditions, the peak wave height can be significantly larger than the average, posing a serious threat to maritime activities. This knowledge is particularly crucial for mariners navigating challenging seas. A tale of two motions: waves versus swells. When interpreting NOAA wave forecasts, it's essential to distinguish between waves and swells. While both are forms of wave motion, they differ in their origins and characteristics. Understanding this difference is crucial for accurately assessing sea conditions. Waves and swells are integral parts of the ocean's rhythm, each playing a distinct role in shaping the sea surface. Waves are generated by local winds and are typically steeper and closer together. They are often irregular in shape and direction, reflecting the immediate influence of the wind. Swells, on the other hand, are generated by distant storms and travel thousands of miles across the ocean. They are longer, more rounded waves with a more consistent period. Understanding this distinction is crucial for various marine activities. Surfers, for example, seek out areas with long-period swells for optimal riding conditions. Mariners, on the other hand, pay close attention to both wave and swell forecasts to anticipate potentially hazardous conditions. Section 6. The Beaufort Scale. Wind's influence on the waves. The Beaufort Scale estimates wind speeds based on sea conditions, helping us understand wave formation. Named after Sir Francis Beaufort, it relates wind speed to sea surface effects. By observing the sea, one can estimate wind speed using the Beaufort Scale. The scale ranges from 0, calm, to 12, hurricane force winds. Each level corresponds to specific wind speeds and sea surface appearance. For example, a Beaufort force of 3 creates small wavelets with glassy crests. As wind speed increases, wave height grows and the sea state becomes rougher. I bet you didn't know how swells and waves can interact with each other and affect perceived wave height. By combining wave, swell, and wind data, you can get a more precise understanding of the sea state. This detailed analysis ensures you're well prepared for any maritime adventure. Stay safe out there, and happy boating!